Hello coders and welcome to another C# fundamentals tutorial. Today I'm going to be telling you guys all about structs. Structs are really similar to classes. In fact, structs can use variables, methods, and constructors within them. So if you need to learn about classes, go ahead and check out the classes tutorial. Otherwise, let's go ahead and get into it. To define our struct, we're going to use C#'s keyword struct, name our struct, similar to how we would name our class. And again, we can use variables, we can use methods, and constructors within our struct. Okay, so the big question of this tutorial that we're going to solve is, do we want to use a struct or do we want to use a class? So we're going to define what each one does at the low level and be able to make our decision from there. Okay, so I'm going to have a struct for position. This is essentially going to hold x and y coordinates for my game objects and my game. Okay, so I'm going to use public, so these coordinates can be accessed outside the class or outside the struct. Okay, so we're going to create a new struct similar to how we create a new class, and we want to be able to access these. So I'm going to use public int x, public int y. Now with structs, we cannot initialize our variables similar to how we can in a class. Okay, so this would be illegal. If we want to initialize our values with a constructor, we can. However, we cannot use a default constructor that takes no parameters. Instead, our constructor must take some parameters. So I'm going to pass in two parameters, one for an initial x and one for an initial y. All right. And what I'm going to do is just set x equal to initial x and y equal to initial y. All right, so let's go ahead and determine what differentiates a struct from a class. Well, I wrote some notes up here for us to talk about here. So a struct is a value type variable, a class is a reference type variable. And what I'm going to be talking about is how a value type is going to live on the stack and a reference type is going to live on the stack with a reference to the heap. Okay, so we have this terminology of the stack and the heap, and let's go ahead and talk about what that is exactly. Okay, so I have an image here defining or sort of representing visually what the stack and the heap is. Okay, so we have the stack here on the left, and then we have the heap on the right. And what the stack is a collection of all of our variables, primitive data types, which I don't have listed here, but primitive data types such as ints, longs, shorts, bools, and all that is considered to be on the stack, and instances of objects go on the stack as well. Okay, so in our previous tutorial on classes, we did define a caveat. So I'll go ahead and let's look at that really quick here. So we have this enemy caveat. Caveat is an instance of the enemy class. Okay, so if we come back to our image, you can see we have caveat and dragon on our stack. And what I was talking about with reference types is that reference types live on the stack with references to the heap. Okay, and so our caveat has a pointer reference to an enemy class on the heap, and the heap is going to be basically all of our memory. Okay, and then we have our dragon, which is the same thing. Okay, so that's an overview of the stack and the heap. Now let's go back to what it is that makes a value type. Okay, so a value type is always going to contain a value. It's always going to live on the stack, and there's no memory overhead. Okay, so we're talking about a lightweight data structure. Okay, and now we have, what is a reference type? A reference type is going to come packaged with a pointer, which is what I was talking about, how we had the instance pointing to the heap from the stack. And then at any time, the reference could be null. So if that pointer isn't there, then the instance variable has a null value. So again, the reference type is going to live on the stack with a reference to the heap, and there's going to be memory overhead with reference types. Okay, so remember, reference types are classes, value types are going to be our structs. Okay, now there's other value types, of course, but a struct is a value type. All right, so again, the question is, how do we determine which one to use? Okay, well, a struct is more lightweight, there's no memory overhead. However, we can't use things like default constructors in our struct, and we can't initialize our variables. So the best advice I could give to you guys, and actually what the Microsoft website recommends is that if you want to use structs, that's fine, but make sure that you're using it properly. So if you have a case where you're instantiating many instances of a data structure, then use a struct. And also they recommend that your structs remain under 16 bits of information. All right. Also, if you're using a struct that's going to be embedded in your classes, that's totally fine as well. So ideally, we would actually put this position struct inside our enemy class so that the enemy would have a position. Okay, and we could just put that above the class definition, sort of how we do it here. Okay, so that talks about that. Let's see, what else did I want to talk about? Okay, so whenever it comes to copying data, all right, if you're copying with reference types, in other words, if you're copying with instances of an object, you can run into some problems. So if I were to say cave yeti equals dragon, okay, this is going to give us some issues. What happens is that cave yeti is now pointing to dragon, and if I modify cave yeti's variables, it's going to modify the dragon's variables as well. So if I were to say console.writeLine, the health of the cave yeti is health. And if I were to write another console.writeLine for the dragon's health, okay. So if I were to write another console.writeLine for the dragon's health, these two values would be exactly the same, believe it or not, because cave yeti is now pointing to dragon. If I run this, you can see that the cave yeti and the dragon now have the same health. Now, why is this happening? Well, if we come back to our stack and heap representation, whenever initially cave yeti is pointing to its own class, dragon is pointing to its own class, its own space of memory on the heap. Whenever I say cave yeti equals dragon, this is what happens. Okay, so notice the pointers. So when I say cave yeti equals dragon, cave yeti's reference pointer now points to the dragon's class and the memory on the heap. So any modifications to the cave yeti result in modifications to the dragon. Any modifications to the dragon results in modifications to the cave yeti. All right. Now with structs, it's a little bit different because structs are actually value types. So let's go ahead and test that. Let's say I create a position, pos1 equals new position 4, 5, and then I'm going to create another position. And remember, these are structs. These are value types. And this pos2 is going to be equal to 45 and 55. All right. Now, if I say pos1 equals pos2, what's going to happen is pos1 is now going to be equal to 45 and 55. All right. However, if I modify pos1.x to be something like 100, well, pos2.x is still going to be equal to 45. Okay, so let's prove that. So position 1.x is okay, so we'll print out the pos1.x and we'll print out the pos2.x to show that that these values are still going to remain different because they aren't pointing to the same thing. Okay, so we should get pos1.x is going to be 100 and pos2.x should still be 45. All right, so let's go ahead and debug and run this. Okay, pos1.x is 100 and pos2.x is 45. So as you can see, even though we copied pos1 into pos2 or pos2 into pos1, modifying either or isn't going to affect the other. Okay, so let's get rid of this so I can show you that this value actually did get copied. So now pos1.x should be equal to 45. There we go. Okay, so in short, let's go ahead and summarize. When do we want to use a struct? Okay, so the question is, when do we use structs? And when do we use classes? Okay, so we are going to use structs when we want, let's see, use when there are going to be many instances, or when it is embedded inside a class. So another time that we can use structs, or whenever we use structs, make sure that the data is under 16 bits of information. Okay, so these need to be pretty lightweight to keep your programs efficient. So when do we use classes? Well, let's see, some of the things that we went over. We use classes if we want to have large data. So if we're holding large amounts of data. I would also add if we want a lot of functionality, and then if we want if we want to be able to initialize our variables, and if we want to have a default constructor. Okay, so these are the instances when we want to use a class. These are the instances when we want to use a struct. Okay, so I hope this tutorial was helpful to you guys. If you liked it, go ahead and subscribe. Please like so that we know that you enjoy these series and we can keep doing episodes of them. As always, this has been a Renaissance Coders tutorial. Thanks for watching.